Hey, so in this module, we're going to talk about profiling both CPU and memory. This isn't going to be a really deep dive into profiling techniques because that could be a course in its own right. My goal is just to walk you through some basic scenarios so that I can show you the tooling and profiling options that Rider provides. Before we jump into Rider though, I just want to show you this documentation. So first of all, they've got really good documentation, which is a great reference, but also there's a few tables in here which is worth pointing out. So if you go to the Rider help and then run, debug, test, deploy, performance profiling of .NET code, and memory profiling of .NET code. Before we jump over to Rider, the things I want to show. So for performance profiling, there's this table showing supported CPU architectures. So this is worth knowing, and you've also got one for supported frameworks for like .NET Framework and .NET Core and Mono. And also on the memory profiling, you've got a very similar table which shows the supported architectures and the supported frameworks. So that's a really good reference. For both of these, for both memory and performance profiling, it's worth noting this bit here. So basically .trace and .memory, they're separate desktop applications, but there's also Rider plugins that if you're using the .NET Ultimate or the All Products subscription, when you install Rider, they will be installed as a default plugin anyway. So if I go to Rider and go to Settings, Plugins, and we'll talk about plugins in the next module more, but if I type in dot, then we can see we've got a bundle plugin, .trace and .memory, but that only applies if you've got one of these licenses. Also, I'm going to be showing the Rider UI for profiling and doing memory snapshots and things. But as I mentioned earlier, there's desktop applications, and there is some functionality that's in the desktop version that's not in Rider. And these are mentioned here. If I go up here, we've got limitations, comparing the standalone version of .memory, some features are not available. Now this might change over time, so again, refer back to this. So that's .memory. If I go to the performance profiling, then we've got a similar note that not all .trace features are available in .NET Rider, and the integrated profiler only includes these two views, which we'll be demoing shortly. So with that, let's move over to Rider and take a look. So I've got this example project which you can download from GitHub, and there are two scenarios. I've got one that does more the performance profiling, and then I've got another one which does more memory profiling. So the performance one is using a Fibonacci calculator, and this is quite a very inefficient implementation intentionally so that we can profile it and see what's going on. And we'll talk about this in the next video. And then we've got another one which just simulates some form of memory leak, which we'll talk about in the video after that, where we'll be talking about the memory profiling side of things. As a side note, you can see I've got a switch statement and I'm displaying some form of menu here. This is just so that I can run it and we can choose from a menu which scenario we want to run. For the menu, so I'm control clicking, this is actually using an amazing library called Spectre Console, which is here if you go to spectreconsole.net. I would highly recommend this if you want to do any kind of interactivity or enhance your console apps in any way. This is by someone called Patrick Svensson, and he actually appeared on my podcast back in episode 14, and we actually spoke about this. But I just wanted to mention the library in case you download the code and follow along and wonder how it's doing the menus. So we can see here it's literally just a prompt asking which scenario you want to run. So if I run that now, Control and F5, this is now running. We've got this menu here, so I can choose up and down which profile we want to run. Before we dig into running and profiling these scenarios, I just want to mention that when you run, and it could be run or debug, it might pop up automatically, but you've got this monitoring pane. So without explicitly profiling, you've already got this kind of graph showing CPU and memory usage over time. I can click on environment and see environment variables, and there's a few buttons here. I'll come back to that in a sec, but if I just click off the memory profiling one as an example, again, in the memory profiling video very shortly, I will dig more into what this is doing, but let's just run that now anyway. Then we can see this graph straight away. So without actually doing any profiling, just as you're working and you're running your app, we've automatically got this kind of information available. There are buttons here, so this is get a memory snapshot, which we'll talk about in the memory video. This one says collect stack trace. And this is really useful actually, just being able to click this and it's going to dump out all the threads and all the stack traces. So we can see here that we're calling that method. And in this, there is a loop and there's a sleep for each iteration of the loop. So we can see it was in that sleep when I clicked on that dump stack trace button. And we can see the same for all these other threads as well. So just little things like that, which are really handy. We can start timeline profiling, which we'll talk about in the next video. And we can also choose when we want to enable this monitoring we're seeing right now. So at the moment, if I debug or run, this appears like we can see. I can choose to never do this or just when debugging. We can also see that because this isn't checked for me, and I think it's checked by default, that causes this to pop up automatically. But as you saw, I had to click on this one to make it appear, because I actually don't like it appearing every single time. So as I say, we get this without thinking about it. You're just running your application or debugging it and this appears. In the next video, we're going to look at doing a more explicit performance profile using this Fibonacci calculator code.